Welcome back, everyone, to another episode of It Depends. I'm your co-host, Elias Khnaser, and today I have the honor of being joined with Sanjeev Mohan, with Anna Bellick, and with Traverse Clayton. Today's topic promises to offer a lot of entertainment, a lot of drama, a lot of blood boiling. So make sure you participate in the comments below. Tell us what you think. Tell us what you thought, how you would approach cloud native. But today, it's everything about cloud native. And just to give you all a heads up, I have it out for Traverse. I'm going after Traverse. So I'm just saying, let's get this going. So Traverse, the first question is going to go to you. Why don't you enlighten us with what the heck cloud native is, especially now that we're hearing about cloud native infrastructure, cloud native applications, and cloud native platforms?
I think that's a good place to start, Eli. And like all good things, vendors are where good terms go to die. So that's what we see with cloud native, right? I mean, everything is cloud native now. But in effect, it's a new way of designing, building, delivering applications. Because guess what? We now have cloud computing. That's what it is. You can treat cloud computing like you used to in a traditional sense. But that was really the inflection point, or the paradigm shift, is when cloud computing came along. You had this notion of elasticity and resources on demand, virtualized networks, all that good stuff that you didn't have in traditional computing. And with that, we see a new way in how you actually can build and deliver applications and architect them in a way to take advantage of cloud computing. That's it. I wouldn't. You can. There's obviously a lot more rabbit holes we're going to get into.
Like what? So, Travis, like for example, like what are those new ways that enhance cloud computing?
Well, that enhanced cloud computing. So, I mean, I can go into my favorite cloud provider and stand up a bunch of machines, and I can treat them like pets, like I do on premises. So I can give them really cool names. And
thank you for using on premises in the plural.
I always, Eli, for at least 8 years, I've learned my lesson. Yeah. But you can give them really fancy names. You like Lord of the Rings, you can call one Gandalf. But guess what? Gandalf is now a living, breathing thing. So you have to patch it. You have to care and feed for it. You have to. It's same like you would on premises, right? The stuff in your data center. You can do the same thing in your favorite cloud provider. The problem is that when Gandalf goes down, everyone's hair catches on fire, right? We instantly have a fire drill. It becomes a problem, and we have to nurse Gandalf back to health, right? But there's a different way to do that. There's a different way to implement scalability within your applications and infrastructure. There's a different way to implement resiliency within your applications and infrastructure, because you have on-demand resources and the ability for that infrastructure to be elastic.
But you still haven't told me what cloud native infrastructure is.
Well, instead of having named things that you have to care and feed for and bring back to life, when they die, and a new one comes into place. You could think of in terms of hardware, hot swappable disks, right? The disk dies, you just put a new one in. In the same sense, we're taking those same concepts and applying them to applications, to infrastructure. When the infrastructure dies underneath your applications, you just bring new resources in. You don't have to nurse it back to life. You don't have to think about it being offline.
But we have
that requires programmable infrastructure.
Right, but IaaS is a programmable infrastructure. And PaaS abstracts everything, including the infrastructure, and gives you a platform to code your applications against that fulfill all of these requirements, no? And by the way,
some PaaS do.
I realize I'm in black and white. I don't know what's going on with StreamYard. It's a bug that I'm trying to figure out on my end, so my apologies.
You look beautiful, Eli.
I think he's
look
stunning.
beautiful. Yeah.
So here's my take.
I'm jealous. My tone doesn't look like that, to be honest.
Here's my take on it. Tell me what you think. I think the confusion with cloud native is what brought confusion to this market is actually the CNCF. the Cloud Native Foundation.
Shots fired. I will fight you.
Well, so hear me out for a second.
I'm Team Traverse, by the way, in case you guys didn't know.
Yeah, but no. Here's the
We're
thing.
Team Cloud Native, Traverse and I. Yeah.
Right. So Cloud Native, the Cloud Native Foundation is obviously trying to push containers and Kubernetes, and there's absolutely nothing wrong with that. But because they're using the term Cloud Native, they've introduced a lot of confusion. So all of the characteristics that you mentioned.
No, I fight you. They did not introduce confusion. They were the first to use that term. Actually, it's their term.
So Cloud.
They created the term.
No, hang
on.
I would argue Pivotal used it before.
Okay, fine, maybe Pivotal, but Cloud Native is like a free and open source thing, so I'm still going to give them the credit.
But so my point is, Cloud Native is a set of characteristics that got its capabilities from cloud. Cloud existed before Cloud Native, right? Sure. Cloud Native is representing the principles that cloud is based on. So whether it's IaaS, but in particular PaaS. So all of those things that we talk about, those are principles that existed before Cloud Native.
No, you're mistaken. IaaS and PaaS are just delivery models, right? Cloud Native is the premise of Cloud Native are the 5 key characteristics of cloud computing. That's what enables.
So that's my point, right? But so these characteristics existed before this term came to be. So when we're saying cloud native, we are referencing what we already learned from cloud computing, which is, whatever NIST has as the 5 or 6 characteristic, Gartner has them, I think, as well. So those are characteristics. The confusion comes in because the CNCF now are productizing it, and they're productizing it around containers and Kubernetes. So now
CNCF is
they don't sell anything, FYI.
Yeah. No, the CNCF is just a vessel for vendors to productize.
I understand, but they are trying to push it's a Linux foundation that is trying to push a container-based approach to cloud native. I mean, it's in their definition. I can look it up on Wikipedia. Wikipedia is my source and show it to you. So
please, no, do not use Wikipedia as a source.
Also, do not listen to Eli.
No, I mean, this is their mission statement, right? Is to advance container and Kubernetes based approaches to cloud native. So everything else from a cloud characteristics perspective applies to PaaS. PaaS was happening before that. Now we're taking all of these characteristics and we're applying them.
So we need to back up a little bit because you jumped into cloud native foundation. There's other things that existed before that, right? And the technologies we see there are manifestations of these patterns and practices that came.
In mind, it's called cloud native, Traverse. So it obviously got its reference from the cloud. So it's taking these cloud best practices and architectures. It's cloud native.
So it's taking, so cloud, cloud gave us elasticity, gave us reliability, all of that. I think where I see cloud native is, again, as always, I'm representing the data and analytics side, is that what cloud gives you out of the box is not enough to meet the needs of today. I'll give you an example. Like even when Google came out with search, that was the first product. They were not cloud native, but they were born in cloud. So they were using all of cloud's abilities. But how was Google search created? It was literally nothing but a bunch of MySQL shards. But once they started expanding and they got more volume, they couldn't scale. So then they invented this NoSQL technology called Bigtable. Then they created Borg, which we know turned into Kubernetes. So that to me is when the inflection point takes off, where you could be Netflix. In Netflix, you pause a movie, you walk away, you come back, you start from where you left 2 days later, let's say. Why? Because Netflix knows exactly where it's keeping that timestamp data. But now if I go to a different country, and now I want to restart. Netflix didn't start to be global. Now it's gone global. Now you need to re-architect what you had built in the cloud in a more agile and iterative manner, so the developers can take these products that they're built and just expose it globally in a distributed manner. So you get this consistent view. So to me, cloud native is the next iteration built on top of cloud technologies. That's how I see it.
So I agree with that conclusion, actually. I think that's kind of what Traverse was trying to say earlier, too, is like there's essentially 2 pieces here worth discussing. There is the scaffolding, right? Like the metal and the abstraction layers on top of the metal that give you that platform of cloud. And then there's what you actually do with it, right? Like you can deploy legacy applications into cloud. Nobody is stopping you. Exactly. That is a cloud infrastructure supporting a non-cloud native application, right? Or you can design your application in a way that takes maximum advantage of what cloud gives you, like massive scalability and all these different services and all this stuff. And that is an application that is cloud native that is running in the cloud. You can actually build applications that are kind of cloud native and run them on-prem, arguably. Like if you go with Traverse's principles of like immutability and cattle versus pets and all that, like you can have a Kubernetes cluster on bare metal that operates in a very cloudy way, but isn't actually in a cloud, right? So there are two separate concepts here of like the architectural pattern or the way you built the application and the actual like garbage hardware you ultimately run it on, like who runs that or whatever.
Exactly. And I agree with that. So there's the cloud native, the characteristics, the patterns, and those are all derived from the first iteration, my opinion, the ultimate iteration, which is PaaS. And SaaS to a certain degree. But PaaS
is the platform. There's nothing like,
but
I mean, the platform enables
everything that you just described, you can accomplish with PaaS. Now, the only difference that you made in your argument was that you can take this and deploy it on premises using Kubernetes. And you're putting all of these characteristics and capabilities.
Okay, so let me challenge you. If I want to talk about application development, right? I want to talk about building software. Right. Should I call it PaaS native software? Would that make you happier?
It has nothing to do with, I'm not talking about the naming right now. I'm talking about the fact that cloud native gave it a thing. It became a thing. If you want to develop against the cloud, yeah, there are APIs from different PaaS services that you can stitch together and create an application. I mean, Traverse is the king of that. He can definitely chime in on that. My point is the only differentiator here is cloud native is being productized around Kubernetes and around containers. And there's nothing wrong with that as long as people understand that these capabilities are native to the cloud, and they're native to the cloud in terms of the cloud provider's platform. That is where it started. Now we're trying to evolve that, if you call it evolution, around Kubernetes and containers and the concept of, well, I can make this portable.
Mm-hmm. Well, let's step back, right? So Heroku, you mentioned PaaS. So I'll go down your path of PaaS. Okay. So Heroku is kind of old school, right? I mean, Heroku's been around. It's like the original PaaS, but people still develop applications on it. And when you develop an application for Heroku, you follow a set of principles called 12-factor apps, right? So we had a bunch of developers building apps on Heroku, and they said, well, if you want to be successful in this type of computing environment, there's these 12 factors that you should follow. And Pivotal came along and called it 15 factors, right? But some of those things are like separating config from code, stateless applications, how you manage state, processes, and all of those patterns exist so that you're building applications that are fundamentally different from like a classic client server application, right? And they can actually take advantage of those cloud characteristics. And so that was a style of building apps to be successful on Heroku. Heroku was an abstraction over infrastructure that enabled application developers to build and deploy apps without having to go through,
that's
IT,
a PaaS,
right? Like I can't tell you how many, you go to any enterprise and talk to developers and like, oh no, I have to go through IT. It always looks like a roadblock. Now I can control my own destiny. I can effectively say, here's my application code. If I follow these certain patterns, I can deploy it, and now I have a scalable app.
It's a PaaS. I agree with you. That's a platform.
So, that's a platform. But
the difference I see between PaaS and cloud native is that from a developer's point of view, it's not that different. You have a set of services, you abstract the infrastructure piece away. But from an infrastructure point of view, with cloud native, you are really taking the utilization, the resources, and maximizing it more than what you did in the first version of PaaS, where you would have a VM that would get started. Now your cloud native means you are exercising the maximum utilization, the maximum power you can derive at the lowest cost.
No, I disagree. So I think that the differentiator between cloud native and PaaS is that PaaS is something that is being offered very similar to what Travers just said with Heroku. It is a platform that is being offered by a vendor. And in AWS's case, AWS has a platform. Azure has a platform. It's a set of capabilities that they're managing, that they're scaling. You're simply using the service. In the cloud natives perspective, the developers have to build all of these services. These, they have the tools, you have the patterns.
Well, it depends on your starting point, right?
No,
so
I completely.
What's the starting point?
I'm gonna now introduce Pivotal Cloud Foundry. So
Pivotal is not. So Pivotal is a private PaaS. Pivotal is a platform.
Let me not. I won't even say.
No one's arguing with you. These are all PaaSes.
No, cloud native becomes a set of tools and capabilities.
Dude, let him finish his story, dude. He's telling you the PaaS story, the history of all PaaS.
No, but these ideas in Heroku, these ideas in Heroku, it's like, how can we now apply these on our own infrastructure and servers? So in comes Cloud Native, or excuse me, Cloud Foundry. And they took those 12 factors, they built on it, and they used that term cloud native as a way, as a set of guardrails to say, if you're going to build new school applications that scale without necessarily the need for completely separate infrastructure, this is how you do it. This is the set of guardrails that you should follow. These are the principles. This is how you build, architect, and deploy applications. And
so isn't this what AWS did with its platform, Travers?
Well, yeah, but you can't call AWS like a platform at that level, right?
Why not?
That's the difference. I mean, AWS is a bunch of building blocks, right? There's no kind of set recipes or ways to do things. And fast forward a little bit beyond Cloud Foundry.
Well, hang on a second. Why is AWS different than Cloud Foundry at the PaaS level? I don't understand. I mean, it doesn't.
I mean, AWS has a lot of things that you might consider PaaS. Elastic Beanstalk is one, which kind of is kind of the old school PaaS, but now they have something called App Runner. So it's really kind of your style of building and running applications, and what level of visibility you want into the underlying infrastructure, and what level of control you want into that underlying infrastructure, right? So, do you want white box, black box visibility? There's all this term of like mechanical sympathy. How much control do you need over that underlying infrastructure, right? If you have a transaction that runs, an application that runs millions of transactions per second, you're probably not going to get away with, your basic PaaS. You're going to need greater control over the, storage subsystems, the networking, how you configure your database and IOPS. A PaaS isn't going to be able to abstract away all of those things for you.
But PaaS offers you the capabilities to tweak your IOPS, to tweak a lot of these capabilities.
Potentially, not all PaaS do. The goal of PaaS is that you don't see the innards of the infrastructure. You're not supposed to need to care about those things, right?
I mean, it's a trade-off, as always, right? It's always a trade-off about ease of use or control. So if you want more control, you give up the ease of use, and then you're not really in a PaaS anymore, or you're in a less restrictive PaaS, less opinionated PaaS, as Gartner would say.
Yes, 100%. I agree with that. It's ownership versus convenience, right?
If cloud native means that the developer's workload is going to go up and they have to worry about more things, I think cloud native has failed. From a developer's point of view, the whole idea, what we are really attempting to do at this point is to take away the infrastructure, what AWS calls undifferentiated heavy lifting, away from the developers. So developers can think more, what does my business need? And less about, which instance type should I choose, So in my opinion, cloud native is all about infrastructure. It is maximizing your infrastructure potential, whether it's multi-tenant or it's, abstracting layers and layers of infrastructure. So the developers, they can write their program, they can use, let's say, Google Firestore, write their, UI front end, and then put it on Google Cloud Run, and not worry about anything like where it goes and how it runs, but they know they're going to get this, consistent user experience regardless.
I agree with you, Sanjeev. Thank you very much. That's a PaaS.
No. So
yeah, that's a PaaS, but that's not necessarily cloud native, right? I think PaaS is definitely predicated on cloud native infrastructure and technologies, for sure. How that manifests itself is, different in OpenShift, is different in Cloud Foundry, or
But Cloud Foundry and OpenShift are both also private paths. They are a system that is being offered to you as a platform that you can put on premises, that you can put in the cloud.
Yeah. And that's why we're going to talk about. That's why we're going to talk about containers. That's why we're going to talk about containers.
Right. So now you're getting to the point. So when we say cloud native,
bring it on.
No. So this entire movement of cloud native is really predicated around Kubernetes. So technically, it is container native.
No, but it existed pre-Kubernetes, Eli. So let's
I understand it exists.
Let's be clear. In Cloud Foundry, you had this idea of build packs, right?
Well, it was called containers before that. I get it. I mean, you can call it VMs if you want to. I mean, you can apply these same principles to a VM too. I mean, you could apply the cloud character. It'll be more complicated. It'll be heavier to do, but you can accomplish the same thing.
The reason I wanted to bring in containers is because a traditional PaaS is very restrictive.
I agree.
You have these certain build packs. They work with these language runtimes and these versions. Even if you look at something like Lambda, which definitely abstracts away the infrastructure and this whole concept of serverless, you're still restricted to a certain set of language runtimes in a certain set of versions. And there's certain constraints that you have within those. So it's not heavily configurable. And that's where we see containers gain popularity, right? So you effectively have two options with PaaS. So, whatever it is, Cloud Foundry, Heroku, you're using build packs. That was one layer of abstraction for developers. But beyond that, it was you had to drop down to a virtual machine, right?
I agree. We're in agreement now.
You fell off the proverbial cliff, right? So you're doing your things in the build packs. It's not quite working for your scenario. Okay, you have to drop down to a virtual machine.
We agree.
Containers comes in 2013, right? Solomon Hykes introduced containers. It says, look, here's he's building, I think it was iCloud, which was some kind of PaaS. But he effectively opened up the insides of how you scale a PaaS and how that works through a container, right? And that's when Docker was born. In Docker now, you gave developers more control over the system configuration that they were aiming for.
I
so
agree.
maybe their build pack didn't quite have this version number, or it didn't quite fit into their language framework or had this dependency. It's like, oh, here you go. Here's a text readable file. You put it right next to your source code. You describe what your system config should be, and then you're off to the races. You're not dependent upon infrastructure or ops downstream.
I agree with you.
And your ability to move from one environment to the next is much more streamlined because there's no guessing, right? It took all the assumptions out of that. And so now, as a developer, you control your own destiny. You're not constrained by build packs. You don't necessarily have to configure an entire virtual machine, which is traditionally INO's responsibility. And you could say, look, in my text file, I want this web server, this OS, these three dependencies, build package my app, deploy, right? So and that's where containers came along. And so that's why we see the huge uptick in containers. The challenge, though, is you were still stuck with running those on virtual machines. You didn't have a way to orchestrate those containers. You didn't have a way to actually move towards this cattle analogy, right? So you still had Gandalf that, even you deployed a container to Gandalf, Gandalf still would need to be resuscitated and cared for if he fell apart, right? And that's where a year later, Kubernetes comes into play, which Sanjeev mentioned, Borg, Omega, projects that originated in Google, gave you a way to now deploy your container, not be constrained to something like a build pack.
So we agree on all of that.
Worry about the self-healing and the orchestration and all that good stuff.
We agree.
But he's orchestrating IaaS now. The Kubernetes layer goes over the virtual machines, right?
I agree.
Yeah.
So that goes to my original point. Cloud native is a set of cloud characteristics. AWS took them and built a PaaS out of them that abstracted everything and allowed the developer to code and not worry about the infrastructure. The differentiator that you are talking about is container centric. It's container native. It's Kubernetes focused. So you're taking the cloud native characteristics that we've been doing for many, many years, metered, self-service, elasticity, abstraction, whatever, and you are augmenting that with Kubernetes and containers. And I'm a huge fan of that. I think that's totally a plus, but that is the differentiator. That's the only differentiator at this point in time. So when you're saying
big one, native, first of all, but second of all, there's two things here, right? The cloud native, like again, back to the idea that the cloud native mantra or like philosophy, if you will, doesn't have to apply to containers. It can apply to other things. You don't have to be a container to be cloud native.
I agree.
It so happens that a lot of containery things are
that's exactly
distinguished as cloud native because we needed some way to distinguish them.
I agree with you. That's what I've been saying. Cloud native is a set of characteristics. The cloud providers built PaaS services from it. Now they're, folks are building this around containers for the idea of portability. It does provide another set of challenges, which means you're back in infrastructure mode, especially when you're doing this on premises. You need a scale out infrastructure. So there's another set of complexity that this type of an approach offers. It's not all roses, but the difference is cloud native. When you say cloud native to someone like me, I think cloud provider platforms. Now, the new thing is some people are trying to define it around container centricity or container native, and they're building all of these capabilities around it. Nothing wrong with that, as long as we acknowledge that, hey, there's this whole thing here called cloud provider platform services.
And I think what you're talking about, right? Like I've heard this as well, right? You're cloud native. What does that mean? Oh, that means we're using the cloud provider services, right? We're using the managed services. So whether that's the database service, a message queue, some other kind of middleware, an event sourcing mechanism, a message bus, I'm using a managed service, therefore I am cloud native. And that's not entirely accurate, right? What that's saying is that because I use the cloud provider's managed service means I'm cloud native, right? But all you're doing is provisioning services and configuring them and, building some kind of application on top of them.
Yes.
And
I mean, okay.
What you're going to offer with containers as well, except you're building.
Those managed services are built around the notion of cloud native infrastructure and concepts, right? So you yourself and the applications you're building by virtue of operating on top of those services, you may call cloud native, right? So
if I'm using, let's say, Amazon RDS, and I go serve an RDS and I pick the instance type, I pick my EBS volume, that I do all of that. Is that cloud native? I wouldn't call
that a managed service.
Okay, can we back up for a second and talk about why anyone cares, right? Like, if cloud native is a badge that you want to wear around so people know you're cool, like, whatever, call yourself cloud native. I don't care. Like, it's stupid, right? If you're talking about actually achieving something or describing an architecture or filling a gap or meeting a need, right? Then it matters, right? So, like, when someone says I'm cloud native, I'm like, okay, I'm Anna, like whatever, right? When you're talking about building a cloud native application, that means something, right? That means you're going to follow some sort of principles that Travis was describing earlier, and that your application is going to look a certain way, right? When you're saying you're offering a cloud native platform, probably you mean that you're providing a platform for someone to try to build the kind of application on, right? When you just say, like, I'm cloud native or like my thing is cloud native, that actually doesn't mean anything. So I agree with Eli in the sense that this word is meaningless when it's used in sort of like generic marketing ways. But I also really want to push back on your like kind of, being mean to CNCF about it, because what CNCF tried to do originally is just come up, like, their vision, their hope, I guess, and their dream was that actually this container Kubernetes philosophy behind them, like the immutability, the kettle not pets, the scalability, that would be the way of the world, right? They thought that was cloud's future, that people who were going to build things that were born in the cloud would do it this way because it's better. And that's why they called it cloud native. It was not because they wanted to market something, right? I mean, they're a free and open source foundation. What do you want from me? Then came the vendors, which, disclaimer, I work for a cloud native vendor, so I'm sorry. But then came the vendors and started saying things like, oh, we're cloud native because we have a SaaS. Like, no, you're not. You're a SaaS. Okay. Or we're cloud native because we use cloud services or managed services like database services or whatever. Like, no, you're not. You're in the cloud and you're, I mean, you kind of are, maybe you are, right? So my point is, like, I would not get hung up on the word, right? The word is just a word. It's marketing. It doesn't matter, right? But you need to get hung up on what someone's trying to tell you when they use this word. So you just ask the question, like,
so
is this?
I have
I mean, since you work for a vendor, so there is
like you don't.
I did read this recent survey, and it's just one data point, but the lifespan of a container, I think 40% is less than 5 minutes. Please don't quote me on that.
Yeah,
but it's a very short lifespan for a container, right?
Yep.
If you were to run that same survey against VMs running in your data center, I mean, if it's 5 minutes, like, you have problems, right? Like,
yeah.
But in a cloud native world,
beyond VMs.
we just finished. In a cloud native world, that is actually not a problem, right?
Yeah.
Because it's expected that things live and die in short periods of time, right?
Yeah.
The life cycle of things is very short. It's expected that you have operational tooling and systems that can react and respond to that.
Exactly.
So your DNS, your service discovery, right? All your networks, all your underlying infrastructure can respond and react to the dynamism of a cloud native world, right?
I have to do it. This is also why, if you look at the CNCF list of vendors, right? This is what Elias is mad about. There's like a huge list of vendors. It's CNCF alleges are cloud native vendors or cloud native open source tools or whatever. Those things were built to accommodate that transition, right? Like what Travis just described as you used to monitor VMs and they used to do a certain thing, operate a certain way. Now we have containers, or now we have these cloud workloads, whatever they are, if they're not containers. They have a different profile and they have different characteristics and they are operationally different. So to do things like monitor them for failure, to monitor them for security, to scan them for vulnerabilities, all that is now different because the structure of these workloads is different. And that's why you have this huge explosion of vendors.
In a traditional world, you have more of a scale up model, right?
Yeah.
And so you have a smaller number of larger things that you want to live for a long time. And you want the availability of those things to be very, very high. In a cloud native world, you have more volume of smaller things. And if those things live and die, that's okay, because you have the infrastructure and the tooling and the patterns within your applications to deal with that ephemeral nature of the infrastructure. And that's the fundamental difference.
Yeah, and here is a great example of how this comes to light. The number one course or class offered in the world by Harvard University is CS50. So we all know about CS50. It's an open source. Anyone in the world can take introduction to computer science class. They have over 1 million people who take this class. So imagine there are all these students from all over the world. They're all logging in, writing their assignment, storing it, and then the deadline comes by midnight. You need to submit all of your assignments if you want to pass this class or whatever it may be. So this class could not even be possible in the first version of PaaS on VMware or VMs, because that the cost of this would be horrendously high. But now you can have 50 containers on one node or one server. So now they can very quickly bring up a container for a student, do whatever they're doing, and then shut it down. So this is where this architecture is sort of the next layer, next version over PaaS. And by the way, since I'm talking, another example I want to give of how cloud native shows up, and I agree, CNCF has led to literally a explosion of products that are now available. So imagine this. Let's say I've written a program where I'm reading and writing to Amazon S3. So I have this business logic that I've coded in Python. Let's say now I want to bring it to on-premises for some reason. So on-premises doesn't have S3, but I can now get a Docker containerized S3 compatible system, deploy it literally within minutes on my on-premises and run my program. So this is the
data is the real problem there, right? I mean, it depends on how you've structured your data, sharding it.
Right.
But yeah, I mean, S3 API has become the industry standard, right? MinIO,
Right.
Cloudflare. I mean, everything has an S3 compatible endpoint at this point. But the real problem is the data, right? So in your scenario, you could run the app and it may work. Point, but is it going to meet the need of the customer?
No. We're talking about two different things. So I'm talking about how cloud native enables me to get an object store up and running on
that's contained. I mean, the whole example is around containers.
Yes, it is. It is absolutely.
That's fine.
Yeah,
I agree. I don't disagree.
Containers are the future, Eli. Get with the program.
No. So I think you guys are missing my point. I'm not, against containers. I
just
believe
saying
in the
that,
technology.
Yeah. You're just saying that cloud native equals containers and Kubernetes. That's what you're saying.
I'm not saying
he's
that.
against calling them cloud native. He
Correct.
says cloud native shouldn't mean containers.
I'm saying
and I'm
cloud
telling him
native.
that he needs to get with the program.
So we need to. We need to wrap up. So everyone, a few minutes on kind of what we learned from this, and I'm gonna start, but we need to kind of wrap this up because we're gonna continue to go back and forth. But let's kind of, for those that are watching or those that are listening, let's see if we can, in 2 or 3 minutes each, let's see if we can kind of summarize what we took from this. So my position on this was, cloud started essentially, in my opinion at least, with AWS. Now, cloud has a set of characteristics. These characteristics are they vary from scalability, from abstraction, from self-service, from metering, etc. We all know the cloud characteristics. These cloud characteristics created the cloud, and the cloud started with AWS and Azure and others. Mm-hmm. When cloud native came along, it's called cloud native. So it derived its characteristics from what was already there. And what was already there were these platforms. So when you tell me cloud native, to me, it's a set of characteristics that AWS picked up or Azure picked up, and they created PaaS offerings. Now, when you said RDS earlier, Sanjeev, RDS is a managed service because AWS is managing, for example, an Oracle database or a SQL database from Microsoft. But DynamoDB, that is a DBaaS as a service in my book. Now, where the confusion comes in is that these cloud characteristics, we can take these cloud characteristics that I mentioned, and we can now apply them against a very agile technology called containers to allow you to get, that scalability, to allow you to deploy in mass, to allow you the flexibility, the immutability, etc., and to allow you to do portability. So my point is, cloud native is an umbrella, is a bucket of characteristics. AWS built a PaaS out of it. A developer can take it and build whatever they want. They can even build their own platform around it. That's my takeaway, at least from this conversation. Definitely not against Kubernetes or containers.
By the way, I don't want to add anything more to what you said. What you said, 100% agree. Just want to say, completing my thought from earlier when Travis said, data is a problem. Yes, you still have to do data migration, but cloud native has given me the power to bring the portability, brings the some of these cloud principles onto on-premises.
Anna, Travis, you want to wrap us up?
I'm going to let Travis go last, but I'll go next. So containers are the future, and the future is now. So just try to keep up is my...
No, I agree. I don't have a problem.
I don't think there's that much of a difference between what you're describing as broadly cloud native and what you want to be container native, because a lot of the underlying philosophy is actually the same. It has also to do with the composability of things, the immutability of things, the programmability of things. It's all kind of down to the same ideas, and some of those ideas are actually not that new, actually. You could argue this is just the Unix philosophy version 37, right? That's just how it is. And it gets better every time, right? I do also want to push back on your dislike of the CNCF, which I think is unfounded. But one important point about CNCF.
My problem with the CNCF is I believe it added confusion, in my opinion.
I disagree with that. I think they had a dream. They defined that dream in a way that sounded good at the time, and now you're here like 7 years later being mad about it because you didn't, whatever, notice. But my point isn't even that. My point is that the Cloud Native Computing Foundation is free and open source, and everything they offer is free and open source. They do not sell products. They're not a commercial entity. They don't make money from selling software.
Yeah, no, I get all of that. So if that was misunderstood earlier, that's not what I meant. What I'm trying to say with the CNCF is it introduced confusion into the market when it should.
No, you're wrong, but forget it. Like, we're not going to argue about this. The point is they have an open source community that is fostering all these projects. And so if there is a large ecosystem of vendors that, in fact, offer commercial versions of these things, which there is, that is largely due to customer demand, right? Those vendors are able to raise capital, they're able to deliver a product, they're able to sell that product to customers. So somebody needs this stuff, apparently, and that's why I have a job, right? But the CNCF itself is a completely like open source community entity that is actually trying to help rather than hurt most of the time.
I'll chime in on CNCF in a minute, but I think about this if you believe that cloud computing is a paradigm shift, there's pre-cloud computing and there's post-cloud computing. Post-cloud computing, you could go from a traditional way of doing things, and now you had more options. One of those options is implementing a set of cloud native patterns and practices. And so everything we talk about, like PaaS, RDS, containers, right? Serverless. These are just manifestations of tools and technologies that implement cloud native.
That's what I said.
That's exactly
what I said.
Yeah. And so when we argue about Kubernetes or containers, I mean, there's going to be something else that comes along, right? I mean, Kubernetes is one orchestrator. There's also Azure Service Fabric. There's HashiCorp Nomad. There's Cloud Foundry. There is OpenShift, which is a derivative of Kubernetes, right? And so there's going to continue to be more and more things.
So how is that different than what I said? Just so I can figure it out.
Maybe we're in violent agreement at this point.
I think we are.
It's all good. It doesn't have to always be a conflict, all right? I mean, come on. We can kumbaya a little bit at the end here. But let me just say one other thing. So now we have Tom Preston Warner, who's the founder of GitHub. And he's like, this whole idea of Jamstack is the future. So we talk about serverless, but now this idea of Jamstack, which is JavaScript APIs and markup, he created a project called Redwood.js. And in that world, I build an application, I connect to APIs, I use markup to describe my application, and then I deploy it on infrastructure that's infinitely scalable. And that's just another manifestation of an application pattern or an architecture pattern that utilizes cloud native concepts, right? And so it's not going to stop there, right? It's going to continue to progress beyond that. And containers is just one little thing, right? It's just a universal packaging mechanism, right? So like Anna has a WAR and Sanjeev has a DLL and you have a PyPy, like, okay, we need a package to deploy this across multiple infrastructure. Let's just put it in this thing called a container, which is now they're calling Open Container Initiative compliant. So that could be a container, it could be a Helm chart, it could be OPA policy, right? It could be any number of things that follow a certain set of open standards. We didn't have that open set of standards for packaging before containers. Now we do.
So I just want to say before we end this, thank you, Travis. That was very well said. To Eli's defense, he was not saying anything negative or CNCF. All he was saying was it introduces confusion. Unfortunately, confusion is who we are. That's what we do in this industry. Last episode, we were trying to wrangle with observability. 5 years, 10 years ago, people were confused about what the heck is big data and NoSQL. Today, I'm constantly trying to unravel what is data mesh and data ops. Tomorrow, it'll be Web3. So
here's the thing. CNCF does provide a vessel for tools and technologies that support small ephemeral things that don't last very long. Traditional tool sets, whether that's monitoring, security, don't work well in that environment.
I think the problem with what I'm saying and I don't know why I can't make it clear enough. If we agree that cloud native is not just about containers, CNCF is just about containers and Kubernetes. That is my problem. That is my problem.
Kubernetes, without question, is the core flagship thing.
I mean, they say it in their mission statement. It's to advance container and Kubernetes technologies. And there's nothing wrong with that. But they're trying to take a term like cloud native and then muddy the conversation.
I mean, there's a lot of telcos that use Nomad over Kubernetes, right? I mean, ultimately, Kubernetes is a scheduler and an orchestrator.
But at the end of the day, like, if you want to blame someone for confusion, you got to blame the vendors, dude. Like,
no. The vendors, of course. No, I agree with you.
Don't blame open source. Yeah. Open source is like
traditionally those orchestrators and schedulers for systems were closed source. Kubernetes is an open source version. It's one of several, but it happens to have the most momentum and groundswell versus the others.
Oh. This was cool. I love you all. Hopefully no hard feelings, no hurt feelings.
We still love you too.
I promise I will fix the video. I don't know why I'm in
I
from
think
the
you should leave
1880s.
I think it's a signature look, Eli.
Yeah.
I hope not for long. But I wanted to wrap up by thanking each and every one of you. I think you guys make these episodes awesome. I hope those of you that are watching and listening are enjoying them. If you are, give us a thumbs up, subscribe, share, leave us a comment. You can attack me all you want. Try to take a few at Traverse and Anna and Sanjeev. Sanjeev's nice, but you know, a few against him as well.
Yeah, I expect you, the audience, to be our fact checkers.
We'll see. We'll see.
I know I said some things that were not right.
It's .cloud.iCloud.
We'll see. We'll see in the comments. So, folks, stay tuned. We've got a bunch of other really cool topics that we've planned out. So, stay tuned. Make sure you subscribe. Thank you so much for watching and/or listening, and we will see you all in the next one.
Thank you.